Welcome to the TechLink Health Podcast, an on-demand source for the top trending healthcare topics and insights. Delivered by key opinion and emerging leaders and as featured on the TechLink Health app. The healthcare industry is rapidly evolving, so our goal is to connect listeners to the most relevant insights, ranging from digital health to financial well-being to interesting side gigs. For more details, visit www.techlink.health.
Well, hey everyone, I'm Dr. Sarah Saman. Welcome back to the TechLink Health Podcast. Today's guest is Peter Adams with the Neuro-Tech company V-Light. Now, in the past on the podcast, we've often talked about how the current era of digitalization and transformation within healthcare and life sciences is an exploration of deep tech as well as science and engineering, creating new approaches to achieving health outcomes. So this trend led to the creation of a range of health tech and medical devices that are leveraging these next generation technologies. These devices include those focused on developing areas of practice such as heart health devices, neurotech, and deep tech, including AI and machine learning. One of the core challenges in scaling these technologies is connected to the themes of adoption and discoverability. So one way to solve these challenges is by making the devices more accessible and capable of remote use at a global scale. We're entering into an era where wearables connected to the Internet of Health Things and Internet of Medical Things will provide paths to treatment, prevention, and even longevity. In fact, the combined Internet of Health Things and Internet of Medical Things markets are projected to surpass $400 billion by 2030, with health-focused wearables reaching $63 billion within the same time period. So in today's episode, we're going to talk about all of this and more as we dig deeper into the evolving space of neurotech, wearables, and the innovative approach of photobiomodulation technology. This episode's guest is Peter Adams, a commercialization consultant and senior executive with expertise building technology-based organizations, as well as developing and implementing strategies and creating market awareness in these key global markets. In the past, Peter has worked as a strategic lead or advisor to organizations such as Intel, McKesson, and Mars Discovery District. Currently, he serves as a vice president of commercialization for V-Light, a company that's leveraging neuroscience and engineering to elevate brain health and neural performance using photobiomodulation technology. So V-Light's published research and patented technology has produced improvements in cognition, memory, and mood. The technology has achieved recognition as a strategic partner with key healthcare and life sciences organizations such as the Department of Veterans Affairs in the United States, where the solution is being used and research to treat traumatic brain injuries. It goes without saying that Peter and the V-Light team have a passion for innovation within the neurotech space, and we look forward to getting his perspectives on the podcast. So without further delay, we're excited to welcome Peter to the podcast. Peter, thank you for joining us today.
Thank you, Sarah. It's great to meet you.
So to start and to give our listeners some background, can you take a moment to introduce yourself in a bit more detail and tell us about your journey in the neurotechnology space?
Sure. I'll try to make it short. My journey is pretty long. Originally, when I gave up being a musician, I was very lucky to get my first job as a bioengineer in the Radcliffe Hospital in Oxford. So I cut my teeth on signal processing and both hardware and software design then. That was my first introduction really to physiological measurement. And from there, I moved on to Canada, an engineering job, and then was fortunate to be one of the first people working with Intel in Canada and went through the whole journey of the introduction of the PC. I moved to California, and from there, my career evolved into strategic marketing. I was fortunate to be a principal consultant at Regis McKenna, one of the first boutique firms there. And then from there, I actually went on to looking at moving technologies across international borders and how that would work. And fast forward, I guess, after another 10 years, after working in Europe, working with the NHS, I went back to Intel, actually asked me to work with the NHS, managing a strategic relationship between Intel, which was both business and technical development. I really learned a lot about healthcare efficiency. Intel was a great partner, monitoring all aspects of the end-to-end flow of information and equipment and people in healthcare. From there, came back to Canada, and I was fortunate to hook up with Mars Discovery District, which is the largest incubator actually in North America, or certainly the largest healthcare incubator, where I was the health IT advisor. And while I was there, they used to give me the oddball stuff, the alternative healthcare technologies, because I'd really followed alternative health, both from healthcare issues and family healthcare issues in the past for a long time. I was obviously very interested in how technology interfaces with the human body. And that's where I met Dr. Lou Lim, and he showed me his first device. He'd actually patented an intranasal approach from delivering light into the nose. And he demonstrated pre and post with somebody who was quite sick, their blood cells. We took a blood sample before, a blood sample after. And within 30 minutes, I saw the platelets disaggregate, and later learned that the viscosity of the blood had actually gone down during that period. And it was later measured using hemorrheology. So I knew there was something there. And so eventually I joined up with Lou as a fractional executive. And most of my work has been in really validating, trying to get clinical validation of the technology. We've come a long way since then. And on that journey, one of the things we found or noticed was there was a rat experiment in Harvard where they were pulsing 40 hertz light into the eyes of rats. He decided to use photobiomodulation for a transcranial device, and that's where we got into the Neuro-Tech business, and it developed from there. So that's what I've been doing since, and we've enjoyed incredible relationships with researchers around the world who have been using this technology and proving it out. So it's been quite a long journey.
That is quite a journey. That's fascinating. The background that you have, both from the standpoint of technology, but also working within the NHS, which for my American colleagues is the National Health Service in England, which has been dealing with a lot of the same issues that we deal with in the United States from perhaps a different standpoint. So thank you so much for sharing that. Now let's talk about the whole neurotech space in general, since that's something you are uniquely positioned to address. And then let's dig deeper into the unique value proposition for photobiomodulation, and particularly as it relates to V-Light. And along with this theme, it's definitely exciting times in this broader neurotech space with the introduction of a range of brain computer interface or BCI devices. So help us connect those dots and let us know what's going on currently in that space and maybe how this is expected to continue to evolve over the coming 5 to 10 years.
Okay, sure. Sarah, maybe a good place to start is what are the mechanisms of photobiomodulation? And then how do you get that energy into the brain? So the first device I talked about in the nose, that was a red light, a red low-powered LED light, and it has a wavelength of 633 nanometers and 655, which is a laser version that you can buy. Now, people were wondering, okay, how do you actually get the light to penetrate and interact with the cells of the brain? And getting the light through the skull, you need enough power, i.e. a longer wavelength. A longer wavelength would be infrared, but the issue with infrared is it gets quite hot, so you can't burn the surface. But at the range of near infrared, that's this sweet spot where you can get the light into the cells. So when it gets in there, what do we know about that it actually does? Well, the light interacts with the mitochondria in the cells of the brain, and the mitochondria have within them a protein called cytochrome C oxidase, which is now known to be able to absorb light and convert it into cell-building energy, or energy that can actually power muscles, power transport of nutrients within the brain, and can actually create growth. So that's a really important aspect to it. The other thing is the light also has an impact on the blood stream. Like I said, it reduces viscosity, and so it increases blood flow, especially in the microcirculation. And this has been already, that's something we already know has been shown. So the combination of these two things has a really important aspect on most diseases. Now, the second part, I mentioned pulsing of the light, and the pulsing part really has different impacts. First of all, it actually resonates with different, let's call it brain frequencies. We have all heard of alpha, beta, gamma, delta. When you pulse at gamma for 40 hertz, the brain tends to resonate with it. And we've shown that it actually induces more gamma activity within the brain. And there are a couple of things that happen. Most clinicians will know that when we're in the gamma state during sleep, that's when a lot of the brain repair goes on, i.e. removal of toxins. There's the increase of the microglia within the brain. And they go around removing toxins, and actually some rebuilding goes on within the brain. So these are very important sort of fundamental aspects of the technology. To date, we've had a lot of partnerships in research. The initial one, we were grateful to have Boston University Hospital, which did some early testing. What happened there was they tested 4 ex-football players who had repetitive head injury. One of them called Larry Carr. He was had extreme suffering, and Larry actually recovered from that treatment. And then they gave him one of our devices, which is a battery-powered, low-powered transcranial device that had actually 4 diodes at the time in the brain and then 1 in the nose. He took those home and he got his life back. I mean, he was a professor. He has a PhD in exercise physiology and psychology, and his whole life had come to a standstill, but he actually reclaimed his life. He went back to Utah. He was a Brigham Young Hall of Famer footballer. He actually convinced them to start researching this further. And fast forward to now, they have 24 researchers who've been doing a number of pivotal studies showing the impacts, which include brain repair using MRI and post, and then literally repair of axons, which they've originally shown through DTI imaging or diffusion sensor imaging. They've shown repair, they've shown reduction in inflammation. So those are some of the things. I mean, I could talk for quite a long time about the data that's being measured during these studies. There are studies all around the world, but I'll leave it to you to guide me to what your listeners might be interested around this subject, because it's quite vast now.
Those are fascinating glimpses into the way this technology works. And I would encourage our listeners to take a look at your website to get a picture of what the device looks like, because it's very interesting. It's sort of like a little cap with a small piece that goes up the nose. Correct me if I'm describing this incorrectly, but it looks like something that wouldn't be uncomfortable to wear. And yet it's something, I personally had never seen, and I was impressed that there is a lot of science behind V-Light. There's a lot of work that's been done looking at this technology and similar technologies, combining neuroscience with engineering and this photobiomodulation with the intent of improving brain health. You've given us some important examples of how this might impact brain health, and would welcome any additional information. And it would be interesting to learn more about what kind of data is collected using the technology, how that data might be used today, and what ways that data might be useful in developing further uses or further areas of interest and research for the future.
Sure. So it's really on a sort of siloed basis, I would say, that under no criticism. It's just that, for example, in Italy, they pursued studies in autism. In Australia, devices have been used for Parkinson's. And in the VA, they've been used for CTE, PTSD, and TBI. And so there have been various aspects that have been collected, though I think what you're asking is there a way all the data can be used at a more aggregated level? So let me just tell you about some of the things that have been collected. So there's been data on memory improvements, processing speed, reaction time, creativity, gait, grip strength, neuromuscular control, data on sleep in firefighters has been done. I mentioned depression, obviously mood. There's a lot of EEG data. We originally were fortunate to work with CAMH, or the Center for Mental Health and Addictions in Toronto, where Reza Zamorodi, who's a world expert on EEG or computational EEG, did a study looking at 3-dimensional QEEG and feeding that into software and looking at heat maps of alpha, beta, gamma amplitudes that were created and to see whether the light was affecting the whole brain. And he showed that it did in 3 dimensions. So there's been a lot of EEG data. We've also done studies on which are more experiential level of meditation. We've had meditation experts use our technology, and that's going to be published shortly. Then there's a lot of data being collected by neurofeedback practitioners, though nothing formally published. But a number of you may or may not know, with neurofeedback, the retraining of the brain sometimes takes 20 to 40 sessions. When you add photobiomodulation, it happens a lot faster. So that's been done. We have also, outside the Neuro-Tech space, we've got COVID data. We actually have clinical approval now from Health Canada for treating respiratory stress from COVID and post-COVID. And then there's a lot of data on microbiome being collected, not using our devices, I have to say. Though what are considered to be neurodegenerative diseases, as your listeners may probably already know, microbiome plays a big part in that. So that's some of the data. Now, on the pulsing side, we've developed a professional device called the Neuro Pro, where you're able to pulse more diodes on the brain at different frequencies, 0 up to 20 kilohertz. And we're really trying to do crowdsourced data collection. We have an early cohort, and we hold group meetings and people share their experiences. That's more ad hoc, but we plan to really scale that up. We're actually developing software to support that particular activity because there are so many combinations of pulsing and light positioning across various parts of the brain. As you can imagine, we're trying to see which of those have greatest influence on those issues. And then some other important pieces of data are, of course, as I mentioned before, which is fMRIs, which really show connectivity and flow in the brain. And that data is really important. Some of the publications that are coming out of Utah shortly are stunning, just showing the impact of light on the brain.
This is really exciting information. You've talked to us about the different ways that the device might impact brain health, including activation of the mitochondria, decreasing viscosity and improving flow of blood, and impacting gamma rays, or gamma waves, I should say. So sticking to that theme of data, help us connect the dots and how the V-Light is able to address all of these various aspects of brain health.
Okay, so it's early days. All I can tell you is what we're discovering so far. So we have shown recently that the introduction of a gamma-based pulse or a 40 hertz pulse will send the brain within 5 minutes of treatment. That's at low power. It will send the brain into what you might call a larger presence of gamma-based brain waves. If you look at the spectrum, of the whole spectrum of alpha, beta, gamma, delta, we're seeing larger gamma. Now, that gamma is also really good for focus or executive focus. And therefore, we found a lot of athletes who pick this up and they use gamma pulse before a game, for example, and they find that they can stay focused much longer. They can get into the flow quicker with gamma and they can stay in a lot longer. Now, the other pulse frequency we use is 10 hertz, which is more in the alpha range. So that seems to instill a more alpha state into the brain, which is more the calmer, let's say, meditative state. So we're finding that a lot of athletes use gamma for a game, and then they use alpha to calm down. For example, if you're a professional football or hockey player, typically you'll want to be focused when the game starts. But then you may get on a plane, you go to a hotel, there's all the excitement, you want to go to sleep. If you use the alpha, that can really help with sleep. It helps with calming, it helps with reduction in anxiety. So those are some of the early known pulse frequencies. More recently, we've been looking at with expert meditators who go really, really deep, and they're finding that the frequencies of around either 4 or 100 hertz really accelerate their journey into deep meditation. So those are some of the things we're finding. It's really early days. I can't tell you to push a button and this is going to happen with a certain frequency. We are finding with the meditation study, the pulse frequencies that affect people in meditation are more personalized. But in general, we've had some great uses of these frequencies by psychotherapists, reducing anger using alpha. And then certainly with post-concussion syndrome or TBI, the gamma has been really useful for getting people more focused and repairing the brain, I would have to say.
That's fascinating. And with meditation in particular, as there are different types of meditation, more focused meditation, more relaxation type of meditation, it's interesting to know that there are a range of effects depending perhaps on the type of meditation somebody might be choosing. It's been well noted that many influential partnerships that Light has established, for example, the U.S. Department of Veterans Affairs through the VA hospital network has been used to treat and evaluate the traumatic brain injuries that are sustained by our military veterans. And it's also been used by high-performing athletes, as you mentioned, with various sports organizations and then first responder organizations like the firefighters that you mentioned that critically need their sleep, and alongside ongoing research by notable universities and other institutions. So tell us more about some of these partnerships and their significance, how you're partnering with these organizations and how that might help to shape the future of the technology and perhaps direct some of the research in the years to come.
Sure. Yeah, so I guess our three VA research centers partnerships have been Boston University Hospital, where Professor Margaret Nazer did an aphasia study. She's done post-concussion syndrome and TBI and published. So she's published outside. And then in UCSF, Professor Linda Chow, who is actually a neuroimaging expert as well, has also done studies using fMRIs. And she did a post-war syndrome study, which helped with returning vets from post-war, which all of these can be read, by the way. These are not secret. They're all published. You can look up Linda Chow. And by the way, navigating through our website to those is probably the best way to go. If you go to the research part of our website, you can find these. Now, in Utah, because Larry Carr was an ex-athlete, Hall of Famer footballer at Brigham Young University, so we've got two universities there. The original study they did there was repetitive head injury. So they had post-war vets, they had ex-football players, some ex-hockey players, and they had, unfortunately, some women who experienced aggressive, violent relationships and had head injuries. So at the end of that study, one of the things they noticed were the grip strength and performance was increased. And so they expanded that study to healthy athletes at Brigham Young. And then they found that there were performance aspects to this. So what I'm saying is that really, when we talk about brain health affects body health, which is kind of unsurprising because we have so many control mechanisms which really control a lot of the things that are going on in the body. And obviously the nerve connections as well, and how those get damaged, and that affects coordination. So that's what really got us excited about doing other studies. And in Utah, they partnered with Brigham Young. Actually, the football team in Brigham Young now is using our devices. The whole team, they have 40 devices, and they are recording everything that's going on that they do regularly throughout the season. We did a one-season study there before, and out of that came increase in processing speed and increase in grip strength over the season. And by the way, for those of you who may not know, but during the season, the playing season, your grip strength goes down and your processing speed goes down as well. Unsurprising, but they found that they actually went up using our technology. So those are some of the things that they've delivered and shown us. Now, the other thing that I think is more apparent has really been the impact of, let's call it small impacts on the head. And what we think of are healthy athletes. When athletes actually come into a university, they're finding actually that they already have post-concussion syndrome to some level. Even microscopic levels can have quite an impact on your performance and health. And I think these are some of the things that these partners are going to show us moving forward, how understanding our current diagnostic capability for concussion and what we call concussion is really rudimentary. And one of the things that Professor Lisa Wild there, who runs that group in Utah, she said, we've been very good at diagnosing concussion, but we never really had a therapy to give them until now. So those are some of the things that they're working on. I'm really grateful to what they're doing. I could go on further, but I think I'll hold there to see if there's something else you wanted to learn.
Those are really exciting implications of this technology. And I think also the fact that you're doing these things without pharmaceuticals is very important. We're always concerned about impact of pharmaceuticals, how that might interact with other medications or with somebody's ability to stay alert and safe. I wonder if there are any downsides to this technology that have surfaced in the course of these studies?
No, that's a good question, because one of the benefits of this technology, it seems to be so harmonious with the human body, and there are no shown contraindications with medication. So patients that are on medication don't need to worry about adding this technology. And in some cases, it's led to reduction in medication. There are hundreds of thousands of devices of various shapes or form of using low-powered LED technology around the world, and there have been no real contraindications shown. The only thing I will say is, just like anything else, there is something you can overtreat, and therefore you get what's called a biphasic response, which may be a sort of a repetition of the symptoms or an increase in the early symptoms. What normally happens is, for example, you might feel head pressure or a headache. But if you just back off for treatment for a couple of days, let it go, and then come back to it. But there have been no severe acute outcomes at all that we've ever recorded, nor our partners, nor any of our competitors. So it's really wonderful. It's a wonderfully safe technology.
That is really encouraging. And what's often the case with many technologies that they're commercially introduced for one use and then the market adapts the solution for unintended uses. And you've already shared some of the unexpected directions that the technology has taken. With this type of kind of evolution that can ultimately sustain the long-term success of the technology and the solution. So along those lines, what are some of the potential use cases for photobiomodulation technology that maybe haven't been explored yet, are only in the early stages? And how will V-Light continue to evolve into the future?
Yeah, well, I think actually Dr. Lou Lim, our founder, just wrote 2 papers. One was looking at all of the disparate research that's gone on around traumatic brain injury and shown why photobiomodulation is making a difference. He's recently done a paper on Alzheimer's disease. One of the things that 40 hertz pulsing seems to do really well is reduce beta amyloid plaques and tau, which are associated with Alzheimer's, but they're associated with a lot of brain injury. So I think that is going to be one of the next big breakthroughs, I think. It's a question, I think, of tuning. Some other research that we've been doing in partnership with the University of Calgary, looking at microtubules, more in the quantum area, it's been shown that certain pulsing frequencies have a kind of a disassembly effect on the microtubules. These are like the quantum wrap around all of the structures that form our cells. And so what they seem to do is to prepare the brain, i.e., when we introduce or induce, let's say, energy into the brain, just like when we induce new ideas to somebody with trauma, the brain is in a more, let's say, defensive state. This seems to relax it, where other things can be induced. So I think that understanding and being able to utilize that is going to really open the door, I think, for a lot of remarkable things, notably things like cancer, for example, which we're starting to think about right now. I can't say that there's any hard evidence yet that this could be breakthrough, but I seriously believe that it will actually in the future be a treatment for cancer once we figure it out. Now, what are some of the barriers to these things adopting? And I think that AI plays a big role, and also in Neuro-Tech, some of the diagnostics. We can talk about that in some detail if you're interested, because I think that one of the things that's actually going to fuel the effectiveness of photobiomodulation will be new real-time diagnostics, and that will be fueled by AI. Now, AI is only going to be as powerful as the amount of signals that we can pick up from the body or biomarkers. And I think there are some new biomarkers that are going to be really interesting that AI can detect that we can't. So I think that's what really will drive some of the new discoveries. and make some of the treatments more effective, faster at the point of care, or even before what we would call detectable right now. So early onset of Alzheimer's, for example, we're going to be really in good shape to do some things about that in the years to come.
That's really exciting. And Alzheimer's in particular is an area of extreme need in our society right now. So, really fascinating insights. And you touched on the integration of this device, and other wearables, other technology, and the Internet of Health Things and Internet of Medical Things devices alongside AI. So, just to kind of go further with that, tell us how V-Light can potentially work alongside some of these other devices and technologies, and any future integrations between either V-Light and AI or V-Light and other technologies that are currently emerging.
Sure. Well, this is early days and there's quite a journey to go. So we are already looking at closed loop feedback, i.e. picking up signals from the body and then adjusting the pulse frequencies or the position of the diodes or the power of the diodes and the duration of the treatment. So we're already looking at that. That's early days, but we're also looking at partnerships to help us do that. Right now, we're very focused on EEG, seeing how we can actually control EEG. We're doing experiments right now with that. So i.e. monitoring the different wavelengths and then seeing how we can adjust frequencies and pulse position to influence inducing gamma into the brain more effectively. So that's one. But down the road, I think that it's really wide open. We're starting to try to figure out how to do crowdsourcing, like I mentioned before. Actually, this is kind of a good advert because we are really open to people who want to participate with us, just collecting data and maybe who are monitoring other biosignals from the body in more effective ways. So there are so many things you can look at. You can look into the eyes, you can look at skin temperature, skin resistance. All of these things are very easy to use. And what the iPhone is able to pick up beyond the visible spectrum, the iPhone can pick up near infrared from the skin and do some remarkable things with AI. So we're looking to partner with anybody who really wants to work on these things with us. It's early days, but I really see that's the trick, is how we can find those sweet spots. And I think what we have to do is we have to do crowdsourcing first and see if any little bubbles come up in certain areas or combinations of frequency and output and change in the body. And then we can go from there and dive deeper. But that journey is not going to be a 5-minute journey, I can assure you. This will be at least a 5-year journey. And then, of course, we have to think about how that's adopted and proved out in clinical trials. So there's quite a lot of work to do there. It isn't about if these things can be done. I'm convinced that these combinations of sensing and then delivery of light or sound, or we're already, of course, delivering electrical pulses. I think those combinations will have almost unlimited potential in manipulating the body and the mind. I really do.
You mentioned the Apple Watch and the iPhone and some of those other kind of ubiquitous wearable technologies. So, on a personal note, what are some of your personal favorite devices when it comes to devices, wearables, and the whole Internet of Health Things, Internet of Medical Things space, and also how those might ultimately integrate with V-Light and other devices?
Well, of course, I really only use the iPhone as a personal device. It is not exactly wearable, but it is a wearable because it's able to monitor movement and so forth. So that's for me. I must admit, I am kind of fascinated actually by some new devices coming out. There is a company in California which I've been interacting with, run by a guy called Shasha Jugme. It's called Level 42. And they have, among other things, they've been looking at ultra low frequencies from the body. And there's a whole spectrum of insights from frequencies below 50 hertz and down to half a hertz, which explain a lot of stuff that's going on in the body. And they have now been doing some great work there using AI. They actually use it to detect COVID in the body, but they're doing some really interesting sensors which can sit in the back of car seats and monitor ECG and blood pressure, respiration in the body, and using AI from it create a whole bunch of insights. Those kinds of things which are able to pick up signals in a very noisy environment are really, really useful. And I think that we have to rethink vital signs, because when you go to this yourself, Sarah, when you go to a hospital, vital signs haven't really changed that much over the last 30 years, other than, of course, fMRIs and blood tests are faster and so forth, and we have ultrasound. But instantaneous vital signs haven't changed a lot. I'm really excited about what instantaneous vital signs that Apple can give us, that Samsung can give us with AI added to it. I think there are going to be some good insights coming from that. Of course, even though those things are exciting, the question is, how does that get adopted into the system, which is another interesting thing possibly to discuss.
Having worked in several healthcare systems, it sounds like you have a very realistic perspective. But I do think that this idea of there are ways to get meaningful vital signs in a very rapid and non-expert way that anybody working in a medical office or in a hospital, an assistant, nursing assistant, for example, would be able to access that could really be meaningful. So, on the topic of emerging health technologies and devices and wearables, what do you see as the challenges and risks and potential dangers? We've talked about the benefits, but what are the downsides that we might need to address along the way?
Yeah. Well, I'm pretty confident now, having worked in healthcare, let's call it system transformation areas with innovation and looking at innovation adoption. I'm quite confident that new technologies are not going to come in at lightning speed where it will create danger. So my feeling is that really the vital signs will have to be viewed and interpreted at a consumer level and accepted at a consumer level, and then gradually be trusted by doctors. I never see doctors, this is like an automatic driving car, I never see them giving away the autopilot in terms of diagnosis and treatment. But what I do see is that when a patient has, for example, being informed by an iPhone that there's a possibility that something's going on and going to the doctor over time will look at it. This whole phrase of doctors saying, oh my God, somebody came in with Dr. Google today. They've been talking to Dr. Google. Very, very frustrating. But I do see that gradually shifting, because they'll see the evidence is getting stronger and stronger. I think everybody knows that. So my belief is that this innovation will come in via the consumer, and the consumer will trust it. The good news is that it will have let's call it a triaging function. Hopefully that will lead to faster diagnosis. We already know that, let's call it manual diagnosis, by far is nowhere near 100% diagnosed accurate on the first visit. If it was 100%, we could solve the whole healthcare problem, because we would then create a 50% increase in efficiency, but it's not happening. So that's the way I see it happening. It's just coming in from the consumer through to the health system.
And I think we are seeing some of that, say, with the EKG monitoring devices. At first there was some skepticism and some of them weren't that good. But from a cardiology standpoint, I can tell you that we've made numerous diagnoses of really serious heart rhythm problems that might have otherwise taken weeks or months to verify. And patient comes in with their EKG strip on their Apple Watch or on their little device, and all of a sudden we're weeks ahead in making a treatment plan and keeping that person safe. So I do see that kind of shifting, again, depending on the accuracy and the science behind the device that the consumer is using. So one of the primary drivers for a new health ecosystem is the cost of healthcare and accessibility at a global scale. So given your role to help in commercialization of this technology, let's talk about the cost structure of V-Light and the broader commercial strategy. So, how can people gain access to the solution, whether it's interested consumers, clinicians, or even health systems, or like you say, football teams, universities, VA systems? What channels are being created for accessibility?
Well, right now, a lot of our devices, the transcranial devices, are between $1,900 and $2,400 US. So they're not accessible to the average pocket, unfortunately. I mean, They cost a lot to make. We're still at relatively low volume, and there's no reimbursement yet. In terms of access to care, we are preparing for a clinical trial for post-concussion syndrome. Hopefully the FDA will award a for-purpose approval. We then have to go through a reimbursement strategy for that. And I'm absolutely sure that the business case will be pretty good. And most payers should pretty much see it compared to what they'd have to spend on rehab, medication, and even from a Medicaid, Medicare standpoint, the cost of the device over time will pay for itself. So not too worried about that. Now, we do have practitioners also that use the device. There are doctors that use it. There are psychotherapists, psychologists, psychiatrists use our devices, and they actually resell them to their patients as an alternative. They still have to pay the full price. We're also looking at financing mechanisms so people can make payments, but that's a work in progress right now that we're doing. So those are some of the things we're looking at. We do have some lower cost intranasal only devices, which are great for sleep, great for energy, and also are really actually quite powerful. Not as powerful as the neuro devices, but they can be very impactful. So those are about $500. Those devices are accessible to more, but we'd really like to see clinical approval on a lot of these. And it's all about investment, money, and time. Nothing happens fast in getting through a reimbursement track on this. We're working hard on it, as hard as we can with who we have right now to get it out to people.
Definitely. And then if we do get approval and have additional data to support the use of something like this, you can imagine, especially for something like Alzheimer's, creating a device like this at scale could be highly beneficial for so many people that the cost effectiveness would be amazing especially compared to some of the medical treatments. So very exciting possibilities. So there's so much going on in healthcare innovation and health tech right now that it's difficult to hone in on all of the developments. And that also provokes the thought of what are we missing? So what, from your perspective, are we not talking enough about that we probably should be?
Yeah. Well, unfortunately, I have to say that outside of healthcare, I think it's really the awareness of what affects health or what keeps people well. And so those things are environment, their social determinants, and what we eat, and the air we breathe, what we drink, what we eat, how we exercise, and then stress, which a lot of stress comes from social determinants. So those are things that I'm not personally working on, though I definitely support and try to help wherever I can. Those are things that will really change healthcare dramatically because we've really changed the landscape of our lives over the last 50 years. So the population, pollution, etc., has changed dramatically. Now, the other thing I think is that we've got to really provide people with data that they can trust in a very friendly form. We've got to keep them out of hospitals. And then the other thing is we've got to delay acute onsets in healthcare. Now, in the American model, other than in the accountable care model, there is no incentive really to delay acute onsets because they increase revenue for health systems, unfortunately, though they do increase costs for Medicaid and Medicare. But reducing acute onsets, which is about predictability. So you've talked about, for example, looking at delaying myocardial infarctions or MI, etc. Those kinds of things, they involve remote monitoring and then prediction and then alerts. So I think it's really about stopping the flow into the health system will reduce the cost dramatically and then reducing acute onsets because the costs go from hundreds of days to thousands in terms of cost of care. So I think those are the basic things. It's not really rocket science, though, unfortunately, because healthcare is so, let's say, tangled, it's in such a mesh, trying to move the whole system is quite challenging.
I'm really glad you brought that up, the impact of the environment, our diet, our lifestyle. It's very easy to overlook those when we get excited about tech, but really the foundation is taking care of ourselves from the ground up. So, in closing, any final advice for those wanting to stay connected to the innovations that are happening in the neurotechnology space, and then particularly with V-Light? And also, we're always interested in topical book recommendations or any other type of content on this subject. So if you have any thoughts you'd like to share with us, we'd love to hear it.
Yeah, I would have to say, having worked at Mars Discovery District, one of the most exciting things that I did there was really to create a clinician ecosystem and a health system administrator ecosystem. So to anybody who's working in the system or even peripheral to it, I would really encourage you to connect with your local innovation incubators. One thing is the technology, but it is really the intersection of people who are really looking into the space, and just go on the websites, go to meetings, and you'll find that very quickly you'll get connected into what's going on. Now, there are other groups like Life Science Integration. CB Insights is a great one. Just sign up for CB Insights. You'll find there's lots of free innovation meetings there. There's actually in Canada, there's Starfish Medical, which are a medical device consulting firm, but they host guests on there. You can tune into Starfish Medical. They have great stuff on diagnostics, really cool stuff on the latest that's going there. And then, of course, universities. So university tech transfer offices, universities always have incubators that are attached to universities, and it's very easy to plug into those too, to find out what's going on there. I don't know one place other than Google where everything meets, but those are some ideas for people where you can connect. I noticed that it's wonderful when clinicians get involved in technology development. It's a great thing. I encourage you.
Well, thank you so much for joining us today. My guest has been Peter Adams with V-Light, and we look forward to seeing you all at the next episode of the TechLink Health Podcast.
Thank you so much. It's been fun.
Thanks for listening to this episode. TechLink Health is a healthcare advisory platform for consumers and organizations to stay informed with the latest insights while connecting with healthcare experts for telehealth, e-consults, and consulting services. For more details, visit www.techlink.health.